Hi, in this tutorial, we have an exercise related to drawing Newman projections. The question in the exercise asks us, draw a Newman projection of the most stable conformation, citing down the C3-C4 bond for 2255 tetramethylhexane. The first step we have to follow is to draw the skeletal structure of this molecule. Let's start. We have hexane. The parent name is hexane, so we should have 6 consecutive carbon. Okay, then let's number the carbons. 1, 2, 3, 4, 5, 6. After that, we should have 2 methyl groups on the second position, and 2 methyl groups on the fifth position. So let's write here 2 methyl, and also let's draw 2 methyl at the fifth position. So this is our line bond structure for 2255 tetramethylhexane, and we should cite the molecule from 3 and 4 carbons. We have to be here, and we should see carbon-carbon bond at the position of 3 and 4. So how are we going to visualize this? So basically, if we draw a Newman projection, and the most stable conformers are always staggered conformers, so we have to draw a circle pointing or representing the back carbon or carbon 4, and we should have a front carbon, generally the center of the circle, which is the carbon number 3. Okay, so let's identify what we have at carbon 3 and at carbon 4. So I'm going to erase something, and I can discuss the things. Okay, so this is, we have here number 3, we have 2 hydrogens, and let's just circle them. We have 2 hydrogens, and this group, which is a T-butyl group. So basically, the front carbon, number 3, which is the point here, uh, representing that front carbon, C3 carbon, it should have 2 hydrogens and 1 methyl group. Just randomly select positions for that. So I will write here as T-butyl. I'm not going to draw the structure there. I will just say it's T-butyl here. Okay, let's come to the carbon number 4. It has again 2 hydrogens, and it is connected with again a T-butyl group. We can again write randomly. I'm going to write T-butyl here for a reason. Hydrogen and hydrogen. So when we have groups coming out of the back carbon, we should start from the circle, drawing them. So I will write this is T-butyl, hydrogen, and hydrogen. So this is one of the conformer, one of the Newman projection of the conformer corresponding to this molecule, but it may not be the most stable one, even though this is a staggered conformer. It may not be the most stable staggered conformer. Okay, let's look at here. Do we have any strain? Yes, we have here T-butyl, T-butyl. They are next to each other. There's a 60-degree dihedral angle, and this is a special type of staggered conformer. We call it gauche conformer. When we have bulky groups next to each other with 60-degree dihedral angle, we call this is gauche conformer, and there is always steric strain associated with this interaction because these are big groups, not like hydrogens. So they interact sterically. There is going to be a strain. So meaning that this molecule or this specific conformer may not be the most stable one. Then we have to basically rotate back or front carbon 120 degree so that we can generate other staggered conformers. So for that reason, I'm going to rotate the back positions 120 degrees. So I'm going to move this p-butyl here. I'm rotating the back carbon 120 degree clockwise. So then this hydrogen should move to the position of this hydrogen, and then this hydrogen should move all the way to the position of this t-butyl. I will generate another Newman projection. Then let's draw that Newman projection. Again, we have to draw a circle and we have to draw the center. Center is the front carbon. So I didn't rotate the front carbon. So front carbon should be stationary. So we have t-butyl pointing up, hydrogen and hydrogen. Now this t-butyl should move all the way here. For that reason, I'm going to write here again. Let's specify this t-butyl will move all the way here. Let's write it here. So that will be a t-butyl coming from the back carbon and pointing down, because what I did, I rotated the back carbon 120 degrees. So this t-butyl should come here. Then this hydrogen should shift all the way here. So I'll draw a hydrogen there. And this hydrogen should go the place of the third butyl. So it's this now. Now let's look at this conformation. When we look at this conformation, specifically, the t-butyl groups are 180 degree apart from each other. The dihedral angle between this third butyl and this third butyl group is 180 degree. So this is again a specific type of staggered conformer, which we call anti-conformer. Like in the normal butane, we have a gauche conformer, which is a staggered, and another staggered, which is anti-conformer. Since the bulky groups are 180 degree apart from each other, they do not interact. There is no strain associated with this conformer. So this is the most stable conformer. And this is also a stable conformer, but it's not the most one. So the least stable conformer or less stable conformers generally are eclipsed conformers, but we are going to discuss in another exercise. Thank you so much for watching the video.